Welcome to my presentation. Today I discuss about mechanism of size reduction. Mechanism of reduction based on several methods: cutting, compression, impact, attrition. The best four method and several equipment also related to this method. Suppose hammer mill is used for impact method, and in this table I try to present this the method and the proper equipment that are used following method and approximate particle size. Mechanism: the main mechanism of size reduction. Here I try to present this. The particle size at the initial stage is very large, and after applied pressure we reduce this size. And here the impact energy plays the main role. To identify this energy, several theory also be developed. Here the particle size distribution with increasing milling time. In this graphical presentation I try to present the relation between milling time and particle diameter. The relation between these two terms is inversely proportional to each other. When milling time increases, the particle diameter generally decreases. The percent frequency generally tell us about this. Now I enter the main theme: cutting method. Cutting method mainly based on cutting mill, cutter mill. Cutter mill consists of two types of leaves. One is stationary, another is rotating leaves. These leaves help to reduce the particle size. When this device rotated, these leaves help to cut the particle and we get our desirable particle size. Here the cutter method, the parameter I try to show the diameter particle size that we obtain from this device. And the graphical presentation: particle diameter and percent of frequency. Particle diameter at the initial stage is very high. After applied pressure or passing time, the particle size generally reduces through cutting method, and the frequency represent this. At initial stage, the frequency is high, and the finally the frequency generally reduce, and the particle size also reduce. Compression: particle degradation by two-digit force. First pair of roll, second pair of roll. The particle enter first pair of roll, their size reduce. Further they enter second pair of rolls and their size also reduce. The graphical presentation also tell us about this. At the final stage, we get a small particle, but at initial stage, this particle size is very high and the frequency also high. And when they pass second pair of row, their size generally reduce. And the third one is impact. Hammer mill, the main equipment. The hammer mill, this hammer, and when the particle enter this device, they are rotating very high speed and break the particle. Finally, we get our desirable size. At the main advantage, we can control the rotation of this device and control the size of our particle. The final one is attrition. The ball mill, the ball, the rotating device. The ball is rotated and push the particle, they break the particle in small size. Here the main scientific term centrifugal force. Centrifugal force mainly present rotating bodies. Here the ball is rotating bodies. From equation we can know the centrifugal force mainly depend on the speed of the ball mill. Here omega, angular speed or radius of the ball, m, the weight of the ball. Now the conclusion in my presentation. As a pharmacist, we have much knowledge about size reduction terminology because in pharmaceutical field, several purposes size reduction is required for the uniformity of the product, uniform flow, proper disintegration, dissolution rate of the drug. We must require the proper size of the particle. Through size reduction procedure, we can get our desirable size particle. Thank you.